Hey everybody, Cub Scout Roundtable Commissioner Jessica Danella here. I'm going to be working on the Bear Elective Super Science. I'm actually really excited about this one because it not only deals with electricity, but it deals with color laying, sinker float demonstrations, and you get to create your own static electricity demonstration. So I'm super excited. I'm a STEM Nova, or I'm a Nova counselor, not a Supernova mentor, but a Nova Awards counselor for my pack in the Pioneer District of New Birth of Freedom Council. So I love STEM. I love working with different experiments. So yeah, let's get started. First, we are going to be doing the balloon trick. I have a wool jacket here, and I'm actually going to do it for my face, or my hair. I'm going to rub this. This is just like my son has little water balloons, so it's a really tiny balloon, but it works. So I'm going to rub this for a couple seconds. See my hair start? I don't know if you can see it. See? Let's see if you can see it. There it goes. So this one's kind of cool. It works. So you just use it, this is just a regular like cotton shirt. Just rub it there, rub it on wool, stick it to your face. It works. We're gonna jump over to my bathroom and we're gonna create our own science experiment. Alrighty, we're back. I'm showing you that we're taking the exact same balloon and we're gonna do the bending water experiment. So I'm gonna take the same balloon, rub it, or first I'm gonna get my water trickling. Okay, get this back in focus, there we go. Woo. Okay, I'm gonna rub it. I'll do it from this side, see if I can. That static electricity moves the water molecules. Okay, we're back. Back from the bathroom. Oh, that was a trip. Okay, so what did we learn? So we learned that not only static electricity works on both wool and cotton with the balloon science experiment, but that it also bends water molecules. So that right there, we just marked off number 1 and number 2. Okay, so the next thing that we're going to do is a sink or float demonstration. I have a tub of water. And I'm going to, hopefully can tilt this. We have a chopstick. It's wooden. I'm just taking random stuff around my house. I walked around my house and said, what do you think could sink or swim? A paper clip. Almost lost it. A penny. Tongue depressor. A rubber band. And an Allen wrench. Okay, so those are my couple things. I'm going to tilt the camera down so you guys can see it, and we are going to discuss it afterwards. Okay, so here's my water. I'm going to start with the rubber band. It floats. Here goes the penny. Penny sinks. See if I can get this. Whoa, too bright. There we go. I don't know if this will... It's okay. We're going to take out the chopstick because it is too long. Tongue depressor. Looks like it floats. Paper clip going in. It sinks. The Allen wrench sinks. So we have 3 things that sank. We have the Allen wrench, the paper clip, which is surprising because paper clips are pretty light. And then we have the penny, and then we have a tongue depressor, which is solid wood, and we have a rubber band. Those are the few things that sink or float. Now that we got our sink or float demonstration out of the way, let's talk about it. So I'm sorry that I couldn't use the chopstick. It was a little too long for the container I was using. But let's talk why. So when you have items that are heavy, because not all items or things that are heavy actually sink. If you think about us in a swimming pool, we are buoyant, and 9 times out of 10 people float. I know I can't float to save my life, but my son can. I'm whatever weight I am, but he's about 70 pounds. And that's pretty heavy, right? I can barely pick him up anymore, but we have buoyancy as people, so we float 9 times out of 10. If you learned properly in swimming class. When it comes to wood's heavy, but not heavy. It's heavy when it comes to being a tree or a project. It's heavy that way, but when it's by itself, it's actually really light. Rubber bands obviously are really light. They can shoot across the room in no time. Pennies are copper. So, and even like nickels, they have nickel in them. So they, that is a very heavy metal. So that's why they sink. Same thing with Allen wrenches. They have that metal in them, so they sink. And same thing with paper clips. So there's our sink or float demonstration. We are going, and that's number 3 in the Super Science elective. And now we're going to go on to the color layering. So I have just a little jar here. I'm not using it. I'm going to put it up to the side. Hopefully I can move you back a little bit. There we go. Okay, so you see this? So I have a few items here that we're going to use for this layering project. I have light corn syrup. I have hand soap. It says we dish soap, but it works the same way. Vegetable oil. Water in the cup. And even though this is a staple right now, I have rubbing alcohol. Rubbing alcohol is, or isopropyl rubbing alcohol is the same density as witch hazel. I have that as well. I chose to use rubbing alcohol because that's what it calls for in the experiment. So, I'm not going to use much, but this bottle's kind of sticky. But I'm going to just pour a tiny bit in. See how it's really thick? That was probably a lot. Yeah, there it is. See, it's really thick. Like, it's not super runny like water. Next is soap. And this is also pretty thick. I'm going to pour it down the side. There we go. These are just random things that are in my house. So you can see, this is the corn syrup, and that's the dish soap. So I'm going to pour a little bit more in here. Dish soap right now is a staple too, so I don't want to use too much. Wash them hands, you guys. And be really careful, because if you look at the thing that I'm holding, it's going to start dripping. So you want to make sure you're not dripping it all over the table. There we go. See how it doesn't mix? Because this is more dense than this. Next is water. So you want to pour the water very, very carefully. Water is, so this line right here is the dish soap, and this right here when it settles, it'll separate the particles. But you can, hopefully you can see it. There we go, right there. That clear spot is the water. Next is vegetable oil. And again, I'm going to pour this kind of right in the, on the side so it doesn't go all over everywhere. Now you see how this is kind of like water? It's really liquidy. Pour it nice and slow. I'll show you. You see the layers? So corn syrup, the yellow is the soap, clear right here is the water, and then your vegetable oil. Last but not least, I'm not going to use a lot of this. I'm really actually going to, that was just water. If I needed the cup. I want to use all this. Okay, so this is rubbing alcohol. Pour it nice and slowly. And you'll see this top layer right here. Oh, maybe you can see it better here. Maybe. Maybe I need a little bit more. Rubbing alcohol smells. Oof. Okay. So it's 1, 2, 3, 4, 5. There's your layers. So when we're talking about layers, we need to think about particles and density. So each item or liquid has different types of particles in them. When you're thinking about layering, and it was supposed to be a rainbow, to be honest with you, but it didn't work out because we didn't have the darker corn syrup and the colors just didn't work out. It's okay. It still works. It's starting to separate even more. But when we're talking about, let's say, corn syrup to rubbing alcohol, the particles are a lot closer together in corn syrup. That's why it's really sticky and not fast moving, because it's more dense. But when you have, let's say, rubbing alcohol or water, even water is, you know, a little bit more or a little less dense than corn syrup. It's runnier, you know, it's runny. It's not just like, my hands smell like rubbing alcohol. But when it comes to, let's say, the dish soap, or even pure vegetable oil, it's, even though the dish soap or the hand soap is, it runs a little bit smoother than corn syrup, it still has that density to it. The particles are just, I'm trying to think how to word it. So think of atoms. Okay, just think of little dots on a piece of paper, polka dots. Okay, random polka dots. Those polka dots, and if they're not super close together, it would just be like a regular polka dot pattern. Think of that being rubbing alcohol. Okay. And actually, do I have a pen over here? I do have a pen. So this is my son's clever badge. I'm just going to use this piece of paper. I'll show you what I mean. Because I feel it. Sometimes I feel when I'm talking, people don't understand me. So I'm going to draw 5 different layers. Okay, 1, 2, 3, 4, 5. This is my layers. Okay, this is the top where there's nothing. So I'm gonna draw the corn syrup, and I do realize that you guys are shaking. Do this on. Now I'm not drawing tiny dots. I'm drawing just a continuous loop, and I'll show you what I mean. I'm just going to draw half. So you see how they're really, really, really close together? They're pretty much stacking each other. That's the corn syrup. Now I'm drawing the dish soap. See how these look more like circles? There we go. But they're still close together, but they're a little bit more farther apart. And then we have water. Still the circles. Still the same type of particles. But they're a little bit further away. There we go. See? And then we have the vegetable oil. They're still the same, but they're a little bit more further apart. And then we have the rubbing alcohol. We're really far apart. So this would be the density. Okay, this is really, really close together. A little bit further apart, little bit, and further apart are the particles to make it less dense. So that is number 5 on the Super Science elective for bears. We completed it all in like 20 minutes. So if you're watching this at home and you're a bear, do this with me. Like I said, these are just random things around my house. If your parents cook a lot, or if you cook a lot, you should easily have the vegetable oil, the corn syrup. You should be washing your hands so you have the hand soap. Water comes from your faucet. And if you, like I said, if you don't have rubbing alcohol, you can use witch hazel. It's the same density. If you don't have a balloon, Google it. Google what science experiments using electricity you can do for this experiment. One thing I do know that you can use is a bowl with salt and pepper in it. Okay, you take a straw, so just a random like plastic straw, and if you roll the straw in the pepper, it'll separate the pepper. It'll cling to the straw, and it'll leave the salt in the water. So that's a really cool one. Another one that I've seen, instead of using a straw, they use a plastic spoon. Works the same way. One thing that I've seen, I'm trying to think. I just saw it and I think I lost it. Anyway, Google static electricity projects for kids or third graders, what have you. Pinterest is a really good one. If you're on Facebook, those DIY craft groups are really good for that as well. Or ask your fellow leaders. Say, hey, you were the bear leader last year. I'm a bear parent, and we're trying to do this for Super Science. What's one thing that we can do? And they'll 9 times out of 10 help you. If they don't, they need to talk to their co-master. Ooh, I almost knocked you over. But that is Super Science to the completion. Again, we worked on number 1, 2, 3, and 5. We are still using the hashtag scouting at home, and I will see you for our next adventure. Bye.